Hi everyone, I'm Aneesh, the founder of DevVoid, and today we'll be looking into the next episode of DSA XAI. In the last three episodes, we solved three other sums from NeetCode.io. Today, we'll be looking into the next sum. But just before that, I have a small little thing I want to talk about, and that is I have this really nice idea regarding a new series that I want to do. And I was curious about your thoughts, and just let me know down in the comment section below. And the series would be something like this. You guys would give me ideas on what you want to be seen developed as an idea or an application that you want to thinking of, and I'll do it in 1 week and upload a video. Right, whatever I can come up with in a week, that's my deadline, and I'll do a video on it, like a demo and whatnot on the project idea, and showcase it. That's pretty much the concept of it. Just a quick 10-minute video, 12 minutes video, depends on the features I can think of from that small idea that you guys give. But you guys will give me an idea, and I will be developing something on that. Okay, and that I would just showcase it after that. Essentially, like a hackathon where you guys are judges and I am the participant. That's pretty much it. And I want to know what you guys think about that and what you want to do with that. But let me know down in the comment section below. Okay. Okay. Then without further ado, let's just begin with the DSX AI topics. Today, we're looking into first. Let's see what all sums we solved. Okay. We solved contains duplicate, valid anagram, two sum, and those are three easy sums that we solved. We're looking into the next category of easy sums, which would be in 2 pointers. Well, let's see what 2 pointers are. But the problem that we're solving is valid palindrome. I have it opened already. I'm just going to close that. And you can see this is the problem. Okay. You can pause the video here, look at the problem, open the link, do side by side. Ideally, that's the preferred way to learn over here. But yeah, this time also I'll be doing it in a little different way. I have my note open in my other screen right here in this side, just because I feel like sometimes I miss things out if I just go in the flow and I tell everything. So I just want to make sure I don't miss anything out. So I'll just be looking into the screen sometimes and, understanding what's happening, right? Whether I'm actually going the right flow, things like that. So I just some things planned as well. But yeah, overall today we'll be solving in three different ways ideally, and we'll see the use case of everything and see the various complexities of all of them. Okay, but let's just start reading the sum first. So the problem is called valid palindrome, and it says a phrase is a palindrome if, after converting all uppercase letters into lowercase letters, uppercase into lowercase, and removing all non-alpha numeric characters, it reads the same forward and backward. Okay, uppercase to lowercase, remove non-alpha numeric. What does that mean? Remove all kinds of symbols and whatnot. Okay, numbers, whatnot. After doing all that, if it reads the same forward and backward, then it's a palindrome. Okay, got it? Let's look at some examples to understand better if you want. But what's the required return items? Either return true if it's a palindrome, or false if it's not a palindrome. So let's take this example. What have I done? A man, a plan, a canal, Panama. Okay. So that, if you remove all the special characters in it, becomes, as a return over here, right? If you reverse this, it becomes the same thing, if you notice, right? That's why it's a palindrome. So what did they do? They removed all the uppercase letters. They made uppercase into lowercase. They removed symbols, they removed spaces, all of those things. And then they reversed the string. And then what did happen? When you reverse it, became the same thing, right? Well, that's exactly the logic we're going to look into right now. But let's understand the problem a little bit more before we go into it, right? And essentially what we're going to do, right? Let's see. They said a man. Let's call a man a. Okay, for a small example. This, Burman ab. Sure, why not? Right. What happens here? We'll put one colon here. Why not? Some more special characters, comma. Sure. Okay. Now, if you see here, right? We'll also make uppercase. Why not? All the possibilities, right? Be symbols, whatever. Right, man. What we'll do now is we will remove the unwanted items and make it into a normal word. So B capital becomes B small, A remains as it is, comma is removed, space is removed, space here is removed, colon is removed. So it becomes BA, MA. It's actually ma'am, not man. And then AB. So what it is? BAMAM AB. That is the actual word. After removing all the unwanted stuff. Now let's reverse this. What does it become? It becomes, starting from the end, B, A, right? A, and then M, and then A, and then M, and then A, and then B. Is it the same thing? Is it the exact same word you're getting? Well, then it's a palindrome. And then we should return true. So what are we doing? We're taking an input. So the system, the logic, let's see. The input is a string, which is just a set of characters. That can be anything like this, right? And the output is true or false, which is Boolean, right? True or false. I'm not using my writing pad, just give me one sec. Okay. Yeah. True or false is Boolean, and then we should write the logic to do this now. Well, we actually just came up with the logic, right? What are we doing the above logic? We did some cleaning, as you might call it. Removed all the unwanted stuff, right? Did some cleaning, right? And then what did we do? Did some cleaning, and then we reversed it, right? And then what did we do? And then we did comparison. Okay, let's do that only. That's our first logic. Clean the string, reverse it, and compare. Okay, three steps. Okay, so I have the code ready here. I think I'm just going to copy paste because just to save some time, right? So I'm just going to copy paste and let's see what's happening, shall we? So let's go line by line, right? We made a new list called cleaned characters. What does it represent? It represents storing only the characters that build up this word. That is, in this example, it just stores BAMAMAB. Cool? That's it. And then what do we do? If character is alphanumeric in this for loop, for every character in the given input, that is, in the example, one by one, go with B first, then A, then comma, then space, and so on. Every character is something that you type in a keyboard. Every character in the given string as the input. What do? If the character that you just pulled out from the string is alphanumeric. What is alnum? Alphanumeric. That is, it's an alphabet. Then we add the lowercase version of it because we don't want uppercase, right? So what do? If the character is alphanumeric, that is, it's an alphabet, then we add the lowercase version of that alphabet to the array or list. So cleaning just happened here. Cleaning is done. But we got an array, right? We got an array or a list. Let's make that into a string by doing this join over here. This join essentially does what is, right? We got an array of B, A, M, A, M, A, B. But these are all characters. Like this. Right? A string is one item, right? With just like B, A, M, A, M, A, B. Like this. As a whole. So we'll join them. We'll join them with nothing in between. That's why we do an empty string dot join. Because we are saying join them with nothing between them. Empty means nothing in between them. So then what happens is you get this when you do that. So this combines all the characters with nothing in between, right? And gives us a string. Okay? What did we do till now? Quickly reiterate. We cleaned, that is, removed all the unwanted logic as planned. This is as planned. There's nothing special logic happening here. It's literally what we thought in the beginning. Remove the stuff, reverse it, compare. That's it. Okay? So we removed it. Now we'll reverse it in line number 9. This is a Python syntax for reversing. Understood? A Python syntax for reversing. What do we do here? We are going to say colon, colon, minus 1. Colon, colon, minus 1. Okay? Colon, colon, those empty spaces represent everything. So the full string minus 1. Reverse. Okay? In the opposite order, you start going. That's what minus 1 means actually. Go through the whole array or list in the opposite order. Not in the normal order, but from back. Okay, that's what it is. So that's what minus 1 represents over there. Now, what happens is, because of that, our reversed cleaned string or S has the reversed string. All we need to do is compare them now. Equal to equal to. That's it. Done. If I run this, it'll be fine. Okay, the problem is I think I changed the function name as well. So let me just quickly fix that. I don't think we need it to be brute force. Okay, so there we go. Well, it has solved it. It's not the really ideal solution, but it has solved it. Okay, we have got the solution. It's done. But what did we do till now? Okay, we cleaned it, we reversed it, we compared it. Just like how we thought in our mind. Clean, compare, reverse. Okay. One say. Let me just take water quickly. Okay. So we clean, compared, and reversed. Done. Okay. Now that's the first logic. If you didn't understand anything in this logic, of course, we can always just take this code. You're right. Go to ChatGPT, put here, and say, let's say you didn't understand the join. What is join doing here? Right? Always reiterate, guys, please. Okay. In this video, we can't cover every single thing. So just put the effort, put the time into learning some things yourself to, solidify your understanding. Ask questions. That's the learning process, please. Okay. Because it's not a one-on-one session or a, where I'm teaching you guys personally. It's very hard for me to, answer your doubts, but always ask in the comment section as well. Right. I will definitely reply to those. Right. So just let's go back and forth here. Let's focus on learning, please. Okay. And if you guys don't get it, you can always just ChatGPT. There's two solutions. Either do this or ask me out in the comment section. Both are fine. Okay. But this is one solution. But this is not a good solution. We'll see why that's the case. Okay. Now, what are we doing here? Let's see one by one. We are doing first cleaning. Right. For cleaning, we go through every item in the array once. So time becomes O of n because of going through every item once at least. Okay. Next, after cleaning, what do? We do a join. Join also implicitly has a O of the size. But this time it is size of the cleaned characters array, which can be something called m, which is less than or equal to n. Okay, why? When you clean something, it has a smaller size than the original string. So, but it can have the same size if there's nothing to clean, right? If you already have B, A, M, B in the given input, then there's nothing really left to clean, right? Then we're good to go already. So, well, that's good news. But that's not so good news for us because the time complexity becomes O of m here for cleaning. For joining. This was for loop. Okay, this was for the join condition. Okay, next after joining we have reversing. Reversing will also require OFM. So reversing also is using OFM. Okay. Finally, what do we do? Equals. Equality, by the way, is also OFM internally. So what is the biggest factor here? If m is less than n, right? So the time complexity can be called as O of n. But it's clearly like, 4 times n almost, right? Which is, something to consider when you compare multiple cases. But for all purposes, for very high values, it is going to be O of n. Okay. Why is it O of n? For loop O of n, the first for loop. Or if you write here, this loop will run n number of times, where n is the size of s. Okay. After that, the join will run m number of times internally, where m is the number of characters in cleaned characters array. Okay. Finally, next step, reversing would again run O of m number of times. Why? Because reversing a string is also something that requires O of m, requires another for loop internally to do something with. Even joining requires a for loop internally. All of them internally require a for loop. You can think of it like that, right? Finally, equal to, even this requires a for loop internally. So 3 of them require for loop internally already, right? So they will take m, and first for loop is n. The highest magnitude is n in this. So we'll tell it as n. Done. Okay. But that's time. What about space? Come on, what's the space complexity? What are places we are storing? Clean characters is one, where we are storing m number of characters. Then reversing it and whatnot, storing that as well. Again, O of m. So pretty much O of m is the complexity for this. But m's worst is n. So that can also be written as O of n. Why? Because the worst case condition is m is equal to n. The largest value of m is n. So space is going to be O of n as well. Because you are storing the characters of the string, right? So yeah. Now let's look at another solution. Okay. The other solution is using the topic that we have, are supposed to use in this, technically speaking, right? So the topic is essentially something called 2 pointers. Okay. We'll do the same thing here also. Okay. Same thing, but there's a small difference. Okay. The first step will not optimize. We'll clean only. Okay. Cleaning will still be as it is, but we'll look at a new format to clean. That's all. A new little small syntax, a one-liner cleaning logic. One line. But the time taken, everything will remain same in the cleaning logic. Okay. Very important to understand that. Okay. Second part is where we'll optimize. Previously it was cleaning, reversing, comparing. We are going to combine reversing and comparing in a unique way. Okay. See, technically, when you compare a reversal, what are you doing actually? Think about it. When you compare a reverse, right? Let's just say ABC, and you compare its reverse. That is CBA. What are we doing here? We're comparing A with C, B with B, and C with A. But if you think about it, you can just do A with C right here, right? Yes or no? Let's take a bigger example. A, B, C, D, E. Comparing with E, D, C, B, A, because opposite, right? A with D, D with B, B with D, C with C, D with B, and E with A. Now note, B with D will be the same as D with B, repeating, right? these two are the same thing. A with D is also same thing. So we can just, without even reversing, we can do a comparison. You see? A with E, B with D, and so on. That's the logic we're going to use here. We're going to use that fact that we can compare the ends A with E and keep decreasing one by one the step until we reach the middle. And that's the logic we're going to use. Okay. What are you going to do? Start the ends of a string. Start the ends. The left side. The left side and the right side. Okay. Compare them. Okay. If they are equal, then go to the left plus 1 and right minus 1 technically. Right. Then compare them. Then go this, go this. At this point, we have reached the center, we can stop there. And there's a palindrome if it reaches there. That's what we'll use as a logic. Okay. Start left, right. Keep going inside. And boom. That's it. How do we know? When do we tell it's not a palindrome? That's also very important to understand. When do we tell it's not a palindrome? Right? We tell it's not a palindrome when you compare left and right and they're not equal. Simple as that. Right? This in our case is not a palindrome. Why? Because the first left and right only fails. So return false. What if we take A, B, C, D, A? This will fail. But after the increase left and right by 1, B and D is not equal. So it will return false over here. Okay. Next we'll take A, B, C, B, A. Compare A and A. True. B and B. True. And we are done. That's it. Because we reach the center, we can return true without worries. And well, guess what? It is a palindrome, right? You can reverse it and you can see it's all correct. So what we'll do for the logic is, again, I'll copy this over here, paste it over here, filter 2 pointers logic, and boom. So what are we doing here? This is very interesting though. What's happening here? We are using a nice little Python syntax, Python helpers, Python functions to shorten things up. Well, this is a new thing though. So if you don't understand it, what do? Boom, take this. What is this? Right? Always. Let's see. What is happening? What is happening here? Filter goes through each character in the string and keeps only the characters where car is alnum is true. So what is it doing? It goes through every character in the string S and checks and keeps the values based on the left side condition. That is, if every character in string S, just pull the characters in string S, which is alphanumeric, right? That's what we are doing over here. In filter, we are pulling out all of the characters. That's alphanumeric using this syntax. And then we are doing lowercase of everything. Why? Because we don't want uppercase, right? That's the whole point of this. So that's why it works. After that, we'll do the left-right logic. Left is 0 because it represents the first index. Right will be length minus 1. That's exactly what I'm doing here. Left is 0, right is length minus 1. Right? And then, while left is less than right, when does that happen? As long as left is in the left, right is in the right. As long as it's not at the center, left is always going to be less than right. Because right will always be on the right side, right? So, and what did I say we're going to do? If it is filtered, if after filtering, the left and the right are not equal, then we know it's not a palindrome, because the palindrome's condition is when you reverse, it should be equal. So at any point of the check, if left and right are not equal, right, we can say comfortably return false, without doubt. But if they are equal, then let's continue and do left plus 1, right minus 1, and keep going inside, step by step. Well, the reason it's called 2 pointers is because of that. We have 1 pointer for the left side, 1 pointer for the right side, and there's 2 pointers moving front, moving one by one towards the inside, right? I don't know why I'm messing up the pronunciation so much, but yeah, left and right, one by one to the inside until you reach the center. And if those checks are proper, it's a palindrome. Okay. So now if I run this, should be good to go, and I can submit this. Boom. Okay. Now let's analyze. That's the important part here. Analysis. Okay. Well, time and space. Let's look at space first because it's easier. So, what's happening in space here, guys? Come on. We're using one constant space every time. At the same time, we are using a filtered underscore s. Okay. We are still using a filtered underscore s, which means we still have a space complexity of O of n. Because we are storing it somewhere, right? We are storing the filtered values, the cleaned values, right? That's O of n only space. But what's the time though? What's the time? Right? What's happening in the time department? Join and filter, right? They both will take O of n. So, even time is still O of n. Sadly. So we didn't really do much. But still faster. Why? Because after the initial part, we have made it faster. It was previously what and all? O of n, O of m, O of m, O of m. So it's technically 4 O of n last time. This time it is O of n, O of n, O of n. We combine 2 O of n's into 1 this time. Okay? Very important. So now, these are coming because of cleaning side. Let's say somehow magically we optimize that as well. Then let's see what happens, right? So I hope you understood till now what happened. If you didn't, definitely ask down in the comment section, right? And of course, you can always ChatGPT. That's the whole point of this course. Everything, if you don't understand, just copy it. The logic, write the logic once so that you get some codes in your head and then ask the questions. That time it reinforces the codes in your head. Okay? Very important. Please. Now finally, we have the last logic. Okay? Which is technically the most optimized solution of the lot. Okay, just give me one sec. Okay, it's the most optimized solution of the lot. And let's see what the solution is. Even this logic uses 2 pointers. Okay, even this logic uses 2 pointers. But what do we do in this logic? Okay, we're going to skip the cleaning process now. We're going to combine every single step in one step. Okay, and what we are going to do is we are going to go from left. Let's take an example and explain. B, A, comma, M, colon, A, B. Okay. We'll take 1 space, 2 space and colon, 1 comma, 1 space. So this, first we'll start with the left and right. Left is going to be this, right is going to be this. So if you compare left and right, it'll do B becomes smaller b. Compare with this b, they are equal. Good to go. Next, our next left becomes this one and this one. A and A, good to go. Next is the interesting part. When we go to the next left, what happens is, right, what happens? What happens is you find a comma. If you find a comma, what do? Skip it. You find a space. What do? Skip it. Okay. M we found, we stop it there. Next, here also. We found a colon, skip it. Found a space, skip it. Found another space, skip it. Found M. Now compare. Good to go. Goes one step here, goes one step here. And we stop there because we reached the middle. Even now, we are using the same logic that we did till now, except we don't need to clean anymore because we can just skip. What does this save? It saves a lot of things for us, which we'll see one by one. For this last code, I'm going to write it down because I think it's better if I write it down this one. So what we'll do is we'll say left is equal to 0. Right is equal to length of s minus 1. Okay? Okay? While left is less than right, that is, it has not reached the center yet, that's what it represents. What do? First thing we do is check. So we'll be like s of left. But the problem is we can't do that yet. Why? Because we have to be like while s of left dot is alum, right? While not. So what do we do here? We're saying if the current left is not alphanumeric, okay, and left has to still be less than right on, otherwise it doesn't work. Okay. Then we'll do left plus equal to 1 and keep going left one by one. If it is not alphanumeric. Similarly, while not of s of right dot is alnum and left is less than right minus equal to 1. Okay. Left plus equal to 1, right minus equal to 1. That's it. Why do you do that? We are cleaning, or rather we are skipping this time. We are skipping non-alphanumeric characters. Okay. And then what we do is if s of left dot lower is not equal to s of right dot lower, then return false. It is not a palindrome at that point, guys. Otherwise, and then we are done. Left plus equal to right minus equal to 1. Return true. So same logic as previous with some additional steps because we have removed cleaning logic. Now let's submit this. Let's see what happens. Okay. Don't look at the speeds on the left side, by the way. Very bad to use as a comparison purpose. But let's look at the R analysis of this. Okay. So what do? We have just one while loop. Okay. Or a loop. So it is O of n time complexity. Why? Because in that loop, we're going from left to the center, which will be n by 2, and right to the center, which is again n by 2. So we're going n by 2, kind of. Okay. It doesn't have to be n by 2, it can be more, but I'm just saying we're going technically from n by 2 or more. Okay. To finish off this comparison. In that case, it will be O of n. But that's it. There's no other special things happening. It's literally just one O of n. Only one place that is affected by O of n. So time complexity is going to be O of n, which is like always, like the previous answers. So there's nothing special there. But the space is very interesting. We have not stored any kind of reversed values or anything like that. We have only kept two variables whose values are always changing, and they have a constant value. That is, they always have only one value each. That's it. Because of that, it's always constant, irrespective of the size of the list or size of the string. And if a space is constant, irrespective of the size of the list or input, then it's called as O of 1. So we have heavily modified the space. But now we have O of n, O of 1 answer for space and O of n for time. That is pretty much it for the best solution. What we do? Left, right. If it is alphanumeric, check that with the next alphanumeric on the right side. Keep going right one by one until you find the next alphanumeric character, that is next alphabet. Keep going left one by one until you find the next alphabet. Compare them. Next, compare. Next. Okay, we reach the center now. Let's stop. Done. That is the logic that we use for the two-pointer logic for valid palindromes. And that is pretty much it, guys. I hope it was interesting. Also, always, the whole point of this course has always been to ask questions either with me or ChatGPT. The point is, you copy this code in the end of the day, paste it here as a context and say, can you explain more in detail of what's happening? Right? So what are we doing here? Let's just see. Check if a string is palindrome, a string that reads the same forward and backward, ignoring non-alphanumeric characters, that is punctuation and spaces. Case differences as well are ignored. And then breaks it down. You see, it's very nice breakdown. I'm just going to quickly go through this, right, so that you guys can see that it's quite easy to learn if you can put the time into it, right? Very important to understand that. And boom, you see, done. That's pretty much it, guys. Definitely go through it. Very easy sum. We can take it off our list now. We're done with 4 sums. I'm going to do more in the days to come. I hope it is so interesting, and see you guys all next time. Comment down, just before that, comment down in the section based on what you guys feel, how the course is going right now, whether you feel anything is not nice from my side. I'll try to improve on that. Let's try to make this effective for both of us, right? I hope everything is good to go, and if you do reach here, comment down saying DevVoid or something like that, just so that I understand that there are people who are actually reaching the end of the video and actually studying properly, right? Of course, always keep learning, keep enjoying, and keep growing. Take care.